In this video, we will be using CurveSuite to generate patches of fur on an existing character model. Unlike previous workflow videos where we went step by step through the process of actually creating the end result from nothing, we will have a different approach where we'll work backwards to showcase how some of the modifiers interact with one another better and how certain workflows can be adapted to create different features. So here I have the workflow example video for the fluffy tail project. And what I will do is go to our asset browser window and bring in a character model. Now I will realize the instances so that we have a actual mesh that we can edit. I will join the eyes to the body itself. I will delete the empty that the collection came with. And then I will scale the mesh. Now that the scale of our base mesh matches the tail, I will bring in a curve object and then we can work towards which modifiers to add to the curve itself. This curve will be our fur patches, so I will name it fur2 to not confuse it with the existing fur object for detail. Now I will mute all the modifiers for now, so that we can go through what each modifier does one by one again. So for the tail project we had this tail mesh that was just a cylinder shaped like a tail. And then we used the cylinders to curves modifier to create curves along the length of the cylinder. Now when generating the fur patches on the mesh itself, the main driving modifier is curves to fur curves, which doesn't work by itself in the setup, which is why we had to use the cylinders to curves modifier, so that the curves to fur curves modifier had something to work with. Now the curves to fur curves modifier uses the radius and tilt parameters of the existing curves to determine the length and the angle of these generated fur curves. And by default, the cylinders to curves modifier generates curves that we cannot really access or modify directly, which is where the transfer radius and tilt modifier came in between these two, so that we had a way to adjust the tilt and angle of the curves generated with the cylinders to curves modifier. Afterwards, we use the displace curves modifiers to create a bit of variation in the shape of the generated fur curves. We also use the clump here curves to clump the displaced curves afterwards. And finally, we use the resample curve modifier to downsample the curves, because otherwise the generated triangles have way too many faces, which would make it unusable in most cases. Now in this particular step, or rather in this particular workflow, we can also use the data transfer modifier to transfer colors, and we can also transfer the custom normals. But unfortunately, this modifier doesn't really work with curve objects, or it doesn't even exist for the curve objects, so that's not something we can talk about until we apply the modifiers. But for this particular workflow, we will still be needing curve to mesh to generate the final result, but pretty much everything else other than curves to fur curves is fully optional. We do not need the cylinders to curves modifier because we're already working with curve objects, so we can just draw our own. Transfer radius and tilt is also not that necessary because we can always just change the radius and tilt parameters of the curves we draw with an edit mode. And displace curves and clump hair curves are already optional, and the main reason we need the resample curves modifier in the first place is because the clump hair curves modifier itself vastly subdivides the curves. Without clump hair curves, you don't really have a need for the resample curves modifier either. So we can select our original fur object and our new curve object, and then just copy your modifiers. And once we select the body mesh rather than our cylinder. We can change the parameters of the modifier itself. We'll also get rid of the material we made for the cylinder. We already have something to work with. We did not even need to do anything, we just copied the modifiers themselves from one object to another. We can always add the modifiers as we need or make changes to the existing modifiers. For example, we can take the profile object, or we can even create a new profile object. We can copy the modifiers as we see fit. Here we have the curves. It's mostly straight, which we can sort out by using the displace curves and clump here curves modifiers. Of course, copying them copies them to the end of the list, so we will need to adjust the modifier ordering accordingly. Previously, with the curves to fur curves modifier, we changed the radius effect on length because we did not really have a convenient access to the radius of the curves that generated the fur curves. But now, since we can edit them directly, we can re-enable this. If you don't want to make adjustments to the different sides, you can always just use the mirror curves modifier, which if we place it, depending on where we place it rather, we get a different result. Or if you place it immediately before curve to mesh, it copies the final result of the curves, which ends up with a issue with the alignment. So we might need to use align curve to surface modifier to fix this. Or alternatively, if we place it after clump curves, it will be the same result. But if we place it before clump curves, the displaced curves will be symmetrized, but then clumping will happen afterwards, so the result will be slightly different. But the curves will still be in the same place. Their shaping will just be slightly different. Or if you place it before even our displaced curves, the displacement will also be different. And finally, if you place it before curves for curves, it will just mirror the generation itself, which will give a roughly identical shape, but the curves will still be different, so it won't be fully symmetrical. By disabling connected only with the proportional editing, you can make proportional adjustments to these curves as well, as long as there are enough control points within the curve to account for this proportional editing. So, for example, in the center area, I have 5 control points, and by editing the center one, I can proportionally edit the other ones. Without the center part, the curve will mostly be the same. The center part will also allow me to have a good point for the proportional editing. And with the way how curves to fur curves works, we can always rotate the control points themselves to control the angle of the generated curves. And as showcased in the previous videos, we can define a vertex group in the base mesh itself, and then use it as a parameter for some of these parameters within the curves to fur curves modifier. In fact, some of the data properties carry over from the generated data, so we could even use some of them for the displaced curves modifier. For example, we can define a group and call it cross. And then here we can use it to define the strength of the cross displacement. If you want some parts to be more messy. The previous workflow videos were quite lengthy because the processes themselves are a bit long and convoluted to get used to. But as you can see, once you're familiar with how the modifiers work, you can very quickly set up new parameters or new objects with the modifiers that still have the similar result or a similar approach, but the end result is useful for different parts. So we can always just convert this to mesh and also bring back our data transfer modifier. Set the nearest face interpolated to blend the normals. And one final note is, once we convert a mesh with the modifiers, all the previously vertex groups or UV maps or color attributes get converted into generic attributes. So now the cross vertex group still exists within the subject's data, but we will need to convert it back to a vertex group within this panel. And not just that, but some of the parameters that are used for technical reasons within the modifiers themselves are also available here. Most of these are not very useful for the average user. If you are familiar with geometry nodes or with how the technical side of Blender works, you may still find a use for them. But in particular, the spline factor group. If we convert it to a vertex group and go to weight paint mode on it, it just blends from 0 to 1 across a curve generated mesh's length. So we can use this as the vertex group input of our data transfer so that the normals are only blended at the root, but the tips themselves retain their own normals. So they still blend in with the base mesh so that the seams aren't really visible, but they still add some volume because without the vertex group defined, looking head on, it's a bit difficult to notice the detail that these fur cards add. I hope despite the shorter length, this video has shown you some useful information and taught you some new approaches you can have to the modifiers. If you have any questions, feel free to leave a comment or contact me directly.